Welcome to lesson 6.4 on predicting products. So, gentle reminder to make sure to title your notes, and this is the one thing you need to be able to do by the end of the video. So far we've been talking about how medications are made. We know the basics of a chemical equation, which looks like this. This is essentially our recipe for how to make something in chemistry. And additionally, our next step is to be able to figure out, okay, if I mix this and this together, how do I figure out that these are the two things that I'm going to make, right? So that's our goal for today. Before we start with the lesson, though, there are three things we need to remember from previous lessons. So from Nearpod lesson 6.3, make sure you still have the 5 types of chemical equations. And then also recall the rule of zero charge. So in our classwork today from Zoom, if I notice that Li has a charge of 1 plus and O2 has a charge of 2 minus, in order for their charges to cancel out to 0, I'm going to need 2 Li's, right? And 1 oxygen with a charge of 2 minus, because 2 Li's together, this makes positive 2, 2 plus added with the 2 minus, so positive 2 plus negative 2 will equal 0, right? Which means in my formula, I'm going to have Li2, because I use 2 Li's, oxygen 1, but I don't need to write the number 1. So Li2O will be my formula in order for the charges to add up to 0. And then thirdly, kind of related to the 5 types of chemical reactions, right? Know that in a chemical reaction or a chemical equation, no new element is ever made. So if I start with Li and O, at the end, I should have at least 1 Li and 1 O. There's not going to be a random element that pops up. Sorry about that. There's not going to be a random element like Na or C that pops up because it wasn't part of our ingredients, right? So the only types of elements I'm starting with before the arrow are the only elements I should see after the arrow. Okay, so let's go through a couple of examples of each of these scenarios in order to predict the product. So every single time we're doing this, we're doing the same 3 steps. I would highly recommend that you pause the video, write down the 3 steps, as well as the type of reaction info, and this screenshots of exceptions. Right. Okay. So in example practice 2, it says predict the product of a chemical equation. And I have the equation NaCl, arrow, blank, and blank. So my first step is to identify which one of these types of reactions is it. So notice I have one molecule in the reactant, and then it's arrow, something plus something. So I'm looking for something where I start out with one thing, and then an arrow, and then something plus something. Do you see which one of the 4 it could be? So here I noticed that in decomposition, there is one thing, arrow, and then something plus something. So when I'm looking for these 4 types of reactions, I'm mainly checking for the parts in red. That seems to be what helps me the most, right? So I start out with one thing, then there's an arrow, and then it's something plus something. One thing, arrow, something plus something. So I know that this is a decomposition reaction, and that's going to help me out a little bit. Okay, so since I know it's a decomposition reaction, mainly what's going to happen is this molecule is going to split up into 2, right? So my goal is to identify all of the charges except for in decomposition. I don't need to do that, right? So if I know that it's a decomposition reaction, it's a little bit different. Basically, I need to find the elements in this molecule and then just split them up in half, and I'm pretty much done, right? So remember that each element is symbolized by at least one capital letter, and the second letter is always lowercase. So in NaCl, I notice that N is capitalized, A is lowercase. So N and A go together. This is one element. Capital C, lowercase l. So Cl is another element. Notice that I also gave you the charges of each element separately, so you can also figure it out that way. So when this splits up, or when this molecule has a breakup, I'm left with Na by itself plus Cl. Right, so I'm just following the pattern of this general structure. One thing will split up into the two things. Right. Now, there is an exception to some of these rules, and that's these elements here. So I, H, N, B, R, O, and Cl, and F will always come in pairs. So these elements will bond to itself again. Notice that Cl is one of them. So instead of just Cl is by itself, it's going to be called Cl2. So elements that bond with themselves always are what we call diatomics. So diatomics are elements that pair up together, right? And there's an acronym that I use to remember which elements will pair up with themselves. And this acronym has maybe a little bit of shade thrown at your friends, but it's helpful to remember, right? So I have no bright or clever friends. The first letter of all of them, except for bright, it's BR, clever is CL, right, is the symbol for all the elements that tend to pair up with themselves when they're separated, right? And when you name these, I2 is going to be called iodine, H2 is hydrogen, just like their original names of their elements. There's no difference, right? Okay. So here, basically our final answer is this part. So let's do another one to try. Okay, same 3 steps again. So here I have the equation Al plus O, and it makes one thing at the end, and my goal is to try to figure out what it makes. So just like before, I'm going to try to figure out which one of these 4 chemical equations or types of reactions it is, right? So here I have something plus something, arrow, one thing is made. Right, so I'm looking for which one of these 4, showing me something plus something, arrow, one thing is made. So this one is one thing, arrow, 2 things at the end. That's not this one. This one is 2 something plus something, arrow, something plus something. It starts out the same, but the end, there's no plus something. So this one, something plus something, arrow, something plus something. Something plus something, arrow, something. So it's not this one. Something plus something, arrow, one thing. Something plus something, arrow, one thing. So this is a synthesis reaction, right? So what this basically means is these 2 things are going to combine into one thing together, right? So in this case, I need to identify all of the charges. So I gave you the charges already. You don't even need to look them up. Let's color code them. So AL is 3 plus. So let's label 3 plus for AL. And O is going to be 2 minus. So let's label 2 minus for O, right? And in step 3, once I figure out what the charges are, our goal is to make the charges add up to 0. So if you don't remember how to do that, I'm going to show you the shortcut method for step number 3. So let's do step number 3 right here. Right, so I have AL is 3 plus, O is 2 minus. So I can either add up the charges over and over again until they add up to 0, or recall that I can also do this. So I'm just going to take the numerical value, so the number 3 and the number 2, ignoring the positive and negative parts, and I'm going to swap them, right? And these are going to be my subscripts for my formula. So to rewrite everything, AL, the 2 from O, is going to go down here, and then I have O, 3, right? So therefore, my product at the very end is going to be AL2O3. And if I double check to see if this works, right? Let's double check that real quick. Here I have 2 ALs, each with a charge of 3 plus. Here I have 3 O's, each with a charge of 2 minus. All right, so notice that if I add all of this up, it's going to add up to a charge of 6 plus. 2 plus 2 plus 2 is going to be 6 minus for my charge. So since they are the opposite values, if I add these two numbers up, it'll add up to 0, so it works. Right? This is just a shortcut version that most of you seem to find easier. Okay, let's do 2 more example problems. If you feel like you kind of got this, feel free to try the questions at the end of the slides, but I'm going to work through these 2 types of reactions, which are the harder ones. Okay, so let's do example practice problem number 3. So here I have K plus NaCl, arrow something plus something. So notice that there's a plus sign before and after the arrow. So if I see a plus sign before and after the arrow, the only ones that are written like that are single replacement, plus sign before and after the arrow, and double replacement, plus sign before and after the arrow. So can you tell which one it is? Is it single replacement or double replacement? Okay, it's going to be single replacement because notice that the first elements, there's at least one element that is a single element, right? It is not combined with another element, meaning it's not a molecule, right? So here, I only see one capital letter K by itself, right? And then it's combining or plus NaCl, which is another element. So Na and Cl are in a bond together, so they're combining together. This one is by itself, so this is our single element. So if you recall, what happens here is it's essentially a partner swap. Right, so for example, the charges, let's identify the charges first, and then we'll talk about what that partner swap is. So K is 1 plus, Na is 1 plus, Cl is 1 minus. So recall that in a single replacement reaction, right, this single element K is going to break up this couple Na and Cl, and it's going to steal one of the partners. It's either going to get with Na or it's either going to get with Cl and kick one of them out. Right. And if we also know that our charges need to add up to 0, then the opposite charges always attract. Right? So the opposite charges always attract. In chemistry, opposites always attract. So who is K going to get with? Is it going to get with Na or Cl? Well, notice that K has a 1 plus charge. So it's going to get with the opposite charge. So it's going to get with Cl because it has a negative charge. They're going to pull towards each other like magnets, and then it's going to kick Na out. Right? So here, Na is going to be single after the reaction all by itself, and K is going to get with Cl. Right? So if I know that K is going to get with Cl, I need to make sure that the charges add up to 0. So K is going to get with Cl. Right? Charges add up to 0. Positive 1 already matches with negative 1. So I just need one of each. Or if I do crisscross method again, I'm going to get the same answer where it's going to tell me I'm just going to need one of each. And also remember that in chemistry, we don't need to write the number 1 if I only have one of them. So it's just going to be KCl. And this is our final answer. Okay, so let's go over the fourth type of problem. So predict the product of this chemical equation. Here I have something plus something, arrow, two other things, right? So in a double replacement reaction, notice that there are no single elements, right? In this last problem, K was single. Here, I don't have any elements by themselves. They're all paired up. And remember, a double replacement reaction is like a partner swap, right? So Mg is currently with O, Na is currently with Cl, and they're going to switch who they're with. So notice that this one is a double replacement reaction because I see something plus something, arrow something plus something, something plus something, arrow something plus something, and there are no single elements by themselves. Each element is bonded or hanging out with someone else. Right. Okay, so step 2, identify all of the charges. Let's put all the charges up top. So Mg is 2 plus, O is 2 minus, Na is 1 plus, and Cl is 1 minus. Right. So again, recalling that double replacement is this relationship and this relationship, they're going to break up and then they're going to trade who they're with, right? So Mg is either going to get with Na or with Cl. And don't forget that in chemistry, opposites attract. So if Mg is positive, it's going to get with the elements that is negative, right? So since Mg is positive, it's going to get with Cl instead. So this will be our new relationship. Mg is going to get with Cl, and O will get whoever is left over, the other opposite charge. So O is a negative charge with 2 minus. So O is going to get with Na because it is the opposite or the positive charge. All right, so now we know who's going to get with who after the facts. Now we just got to write them down in our chemical equation. All right, so Mg is going to get with Cl. Let's make sure our charges add up to 0. So Mg, 2 plus, Cl is 1 minus, so let's crisscross. So therefore, I'm going to have 1 Mg, but I don't need to write the number 1 down. Cl is going to be 2. All right, so one of my products is going to be Mg Cl 2. All right, my other product is going to be O with Na. Right. So something I should also mention at this point is that the positive charge always goes first. We learned that last unit. You might have forgotten it, but just reminding you now. So Na is the positive charge, so that one's going to go first. O is 2 minus. So just like we did with this one, let's figure out how many of each we need when they get together. Right, so the 1's going to go down here in this corner. O is going to go down here in this corner. So I'm going to have Na, this green 2 NAs, O, and then the 1 O, but I don't need to write down the number 1. All right, so my answer for my second product is Na 2O. This is my final answer. So again, the key things to remember is the general structure of these, right? So the parts where we write out the letters A plus B, arrow AB, right? Things like that will help you figure out the general structure. Don't forget to identify the charges. Don't forget to make sure to swap the charges. And don't forget to check the exceptions. There's a lot of steps to these, right? So be very clear about which step you're on. Okay, and as always, feel free to ask if you do need any help. And at this point, you should be able to solve the quiz questions on the next slides at the end.